In this video, I'm going to be talking about the rational root theorem, which tells us all of the possible rational roots of a polynomial. So this problem says determine all possible rational roots of the polynomial f of x equals 9x cubed minus 5x squared plus x minus 2. Now the rational root theorem states that if I take the factors of my constant term and divide any of those factors by the factors of my leading coefficient, then I will get all the possibilities for my rational roots. They might not actually be roots, but any roots that I have of my polynomial function have to come from the list of numbers that comes from factors of this number divided by factors of this number. So what I'm going to do is I'm going to take the factors of my constant, factors of -2, and I'm going to list those out, and I'm going to divide them by any factors of my leading coefficient 9. So factors of 2, I've got 1 times 2, so I've got 1 and 2, and as long as I make one of them negative, so I could have a positive 1 and a negative 2, or I could have a negative 1 and a positive 2. So I'm going to say plus or minus 1 and plus or minus 2. And for 9, I've got either 1 times 9 or 3 times 3, and I'm only going to list the number once. I'm not going to repeat it. So I've got 1, 3, and 9. And again, I need positive and negative because I could do -1 times -9 would also give me a positive 9. So all the positive negatives for my factors of 9. All right, so now if I want to find my complete list of possible rational roots, then I need to divide all of my combinations here. So let's take both plus or minus 1 and plus or minus 2 and divide them first by plus or minus 1. 1 divided by 1 is just going to be 1, so plus or minus 1. And 2 divided by 1 is just going to be plus or minus 2. Okay? Next up, let's take 1 and 2 and divide them both by plus or minus 3. So I've got 1 over 3 would be plus or minus 1/3. And I've got 2 over 3 would be plus or minus 2/3. And finally, let's take both of these and divide them by my last option for my denominator here, plus or minus 9. So I've got 1 over 9 plus or minus 1/9, and 2 over 9 plus or minus 2/9. But if we simplify that, that gives us 1/3. So I actually already have all of my possibilities right here. So just from looking at the polynomial, I've already got 1, 2, 3, 4, 5, but positive and negative means 10 possible rational roots for this function. Not all of these will be roots, but these are my possibilities. Remember, if at any point we're asked to check them, or we want to check them to see if they are in fact roots, one strategy to do that could be to use synthetic division. So let's pick one of these numbers just to show how we could test one if we needed to. Let's say I wanted to test -2 and see if that's a root. I could set up my synthetic division and say 9, -5, 1, and -2 from my coefficients. And then bring down my 9. 9 times -2 is -18. -5 plus -18 would give me -23. -23 times -2 would be positive 46. 46 plus 1 is 47. 47 times -2 would give me a -94. And -94 plus -2 would be a -96. So notice my remainder here is not equal to 0, which means that x plus 2 is not a factor. So x equals -2 is not a root or a 0. So it was a possibility from our list, but it isn't an actual root or 0.